page 91 when we're done. Now, what if I was to tell you that you have actually been calculating things in radians since about 6th grade and you just didn't even know it? Possible. I know, I'm a liar. I think it's 6th grade. I know it's not later than that, so maybe 5th grade. I don't know. They keep kind of changing. They keep pushing everything down. So at least by 6th grade, you learn about circumference and area of circles and things like that. I think if in the 6th grade curriculum, but they may search all 5th grade. I don't know. But anyway, so think before you start. I want somebody to tell me the circumference formula of a circle. I think before you speak, it's easy. The wrong thing a lot of times comes out. Right, 2 pi. Okay, so 2 pi r, right? And you can derive this by not knowing anything about radians. One of the things that I would to do in 6th grade, sometimes it happens. But you can take a piece of string and you can put it around a circular object like a can, like a Pringle can or something, and find the circumference and then also measure the diameter and find the ratio. And you do that with a few different things, and you see that the ratio that you get every time is pi. Because it's defined as the ratio of the circumference to the diameter. So 2 times the radius is the diameter, right? And then if I just divide by the diameter, pi, that's what pi is. It's the ratio of the circumference to the diameter of a circle. I kind of come up with it. Nobody talks about radians, nothing, and that's all fine and great. But 2 pi in radians, now that we know radians, how far around the circle is that in radians? It's 1 full rotation, right? This 2 pi is 1 full rotation in radians. Okay, does that make sense to you? Now let's think about similar figures. All circles are similar to each other. Do we agree with that? The similar figures have the same shape but a different size. Every single circle has exactly the same shape, right? Because if it doesn't, then it's not a circle. So all circles are similar. This right here, 2 pi, is the circumference of a unit radius of 1, right? So if I take that 2 pi and I multiply it by a radius other than 1, basically that just ends up being the scale factor. Does that make sense to you? So that 2 pi is 1 full rotation in radians, and then when the radius is not 1, it just changes how big or small the circle is. Does that make sense to you? Now, radians, when you learn about radians, you learn that when we actually put little sticky strips around the circle in geometry, that a radian for theta, it is the circumference, it's the ratio of the arc length to the radius. And arc length we use lowercase s, y, I don't know if that's what it is. Okay. So for a unit circle, the radius is 1, right? So the length of the arc is the degree measure in radians. So these 2 things right here are kind of the same thing either way. When we do arc length in geometry, we're doing it in degrees. The actual formula looks crazy and weird because there's actually a conversion built in to convert it to radians. I just don't know that that's what's happening. Because of that, I don't like that formula, so I always teach it as a proportion, right? If I just want to arc length, this arc length is just a piece of the circumference, right? So we can take the whole circumference over 350, set it equal to the arc length we want over whatever the angle measure is. And then it's just a proportional relationship and we cross multiply, right? Well, you have to do all that stuff because it's in degrees, and in the midst of that, conversions into radians happen. But because this is in radians, it makes it way easier. And circumference is the theta, which is 2 pi, the whole circle, times r. If all I want is a piece of the circumference, then my degrees aren't 2 pi. It's whatever the arc or whatever the radian degree is, the radian measure is. Same thing here. If I solve for s, I can just multiply both sides by r, right? So my arc length formula here is actually s equals r theta. And that's what this is here for the circumference. It's just when theta is 2 pi, you're finding the whole circumference. If theta is not 2 pi, then you're finding an arc length that is either the entire circle. That's where it comes from, because you've been using radians and didn't even know it. Okay? So this is our arc length. Way easier when it's in radians, because you don't have to do proportions. The formula isn't weird. The arc length is equal to the radius times the angle measure. But theta has to be in degrees. Okay, everybody good so far? This is a super simple simple formula. We are going to work most of these though because I want to talk about how to handle some of these fractions, because in this the formula isn't difficult. The radians aren't even difficult. It's the computation and how to think through it and not make your life harder. That's where some of y'all are going to struggle. This says here, find the length of the intercepted arc given the angle measure and radius. Give your answer in terms of pi and round to the nearest thousandth. So we're going to mark that out because I changed my mind on that. We're going to leave everything in exact form because you need more practice with how to handle this and do this correctly and do things easier, make your life easier instead of doing it the hard way. Okay, so I need S equals, all I'm doing is S equals R times theta. Do you know the radius in number 1? Yes. Do you know theta? Yes. Is it in radians? Yes. Substitute it. Right. So S is equal to the radius, which is 3, times the angle, which is 5 pi over 6. Reduce before you multiply. So that means I can cancel out the 3. 3 goes into 3 once, goes into 6 twice. My arc length is 5 pi over 2. What do the units look like here? Feet. And that's it. Now that one's a super easy one. Some of these you're not going to need my help with, but we're going to just work through them quickly. Now, when you leave these in exact form, when you're giving decimals, you don't mix decimals with pi, you don't mix decimals with square roots. So they need to be in fractional form. This isn't a Misfinin rule, okay? I can show you the keys to the things that look like this that don't come from me, and it is all in complete fraction form, even when you're given decimals. So we need to change those decimals to fractions. Some of them are easier than others to do that with. 14.5, you making that into a fraction should be pretty easy anytime it's a 0.5, right? So 14.5 as an improper fraction would be what? 29 over 2, right? So 29 over 2 is what we're really using here for the radius. And then I have the theta, it is in radians. So S is equal to R theta, so 29 over 2 is the radius, times pi over 4. Can I reduce that at all? No. So then that means S equals 29 pi over 8, and my units are inches. Enthusiasm is good. It's great. All right. Number 3, I have my theta. This 0.5 would be what as a fraction? 1/2. 1/2 times theta, which is 3 pi halves. And that means S gives me 3 pi fourths because I cannot reduce anything, and that's yards. All right, so 6.2. If you were going to say that correctly, because 6.2 is not really the right mathematical way to say that, you would say that it is 6 2/10. That's how you actually read that as a decimal. So if I write it down that way, 6 2/10. Now, can I reduce the 2/10? Yes. That reduces to 1/5. So I already have 6 1/5, but I need it as an improper fraction. So what's that going to be? 31 over 5. So do you see the thought process there without making your life any harder? Reduce before you multiply always. So I have my theta. I have this. So S is equal to the radius, which is 31 over 5, times theta, which is 2 pi. Can I reduce anything? No. So this becomes 62 pi over 5. And it's yards also. How does this arc length differ than the other 3? Look at your theta. It's the whole thing. This is actually the circumference, right? Since theta is 2 pi, it's actually the circumference, even though we're talking about it as arc length, because that's one full rotation. And one full rotation, as far as arc length is concerned, is the circumference. So this arc length really is the circumference here. All right, so let's look at number 5. Number 5 is in degrees. I want it in radians. Now, if it's not one of the special angles that you know, you can convert. However, you think before you just jump in and do math, you can make it a lot easier. 15 degrees isn't something I necessarily expect you to just know. However, do you know what 30 degrees is in radians? What is that? Pi over 6. So if 30 is pi over 6, what is 15? Pi over 12. See, it didn't take any conversion there at all. But if you don't know your measures, you're going to convert and reduce and do all that stuff. Then 8.4 can be 8 and 4/10. We can change 4/10 to 2/5, which means as a fraction, what is it? 42/5. So f is equal to r, which is 42/5, times theta, which is pi/12. Reduce before you multiply. Can I reduce? Yes. What can I reduce by? 6. 6 goes into 42 7 times, goes into 12 twice. Am I reduced all the way? If you reduce everything you can before you multiply, after you multiply, you can't reduce anymore. And it's way easier to tell if you're reduced all the way when everything's split up. So that means that S here is equal to 7 pi over what? 10, and that would be meters. So 330. Now, you may just know what the radians are, but not everybody does. So here's another way to look at it. In degrees, what is my reference angle for 330? 30, right? My reference angle for 330 is 30, because it's going to take me 30 degrees to 360, right? So what is 30 in radians? Pi 6. So pi 6 is my reference angle. What quadrant am I in? Fourth. So a pi 6 reference angle in the fourth quadrant would be what in radians? 11 pi over 6. If you know your reference angles and how to think about that circle, you should be able to get there pretty quickly. 10.5 as a fraction would be what? 21 over 2. Good. Everybody with me on all that? So now this gives me x equals my radius, which is 21 over 2 times 11 pi over 6. I try and reduce before I multiply. 3 goes into 21 7 times, goes into 6 twice. Can I reduce any more? No. So I multiply and I get S equals 77 pi over 4. Again, if you just multiply and then reduce, that's not wrong, but you're making it harder on yourself to make sure that everything's reduced enough. Sometimes it's good to just carry to the next step even. Some of the things we're going to do where you just kind of leave it broken up so you can do one more thing and then clean it all up before you actually multiply. Just make it easier in the end. Okay. So then let's look at 7. Got 120. What is 120 in radians? So you can think of this a couple different ways. First of all, what would the reference angle be? In degrees. What's the reference angle in degrees? 60. Okay, because 120 is in which quadrant? The second, right? 120 is over here. My reference angle here would be 60. In radians, what is that? 60 in radians. Everything. So pi thirds is the reference angle. The pi thirds angle in the second quadrant is what? Pi thirds. So another way to look at this is, if you know that 60 is pi thirds, 2 times 60 is 120. So 2 times pi thirds is 2 pi thirds, right? There's different ways to think about how it works, whatever makes the most sense to you. But you know it can't be more than 3 pi thirds, because 3 pi thirds gets you to pi, right? So it has to be less than that. All right, then this 1.8 would be 1 and 8/10, which we change that to 4/5, which as an improper fraction is what? 9 over 5. So then my arc length is the radius, which is 9/5, times theta, which is 2 pi over 3. Can I reduce? Yes. 3 goes into 9 3 times, into 3 once. So S is equal to 6 pi over 5 feet. Any questions at this point? All right, 135. What's my reference angle in degrees? 45 degrees. Which quadrant am I in at 135? Second quadrant. So your second quadrant angle in radians for 45 degrees is what? 3 pi over 4, because this is pi fourths, right? 2 pi fourths, 3 pi fourths. And then my radius they gave me, I don't have to do anything with that. Is 25 times 3 pi over 4. Can I reduce? No. So this just becomes 75 pi over 4 kilometers. So you'll get a little bit of practice of the unit circle stuff in this if you actually practice it that way and don't just cheat and look on your unit circle. Any questions at this point? All right. So it says central angle theta in a circle of radius meters has an intercepted arc length. Find the measure in degrees. So S is equal to r theta. What am I looking for here? Theta. I'm looking for theta. So that means I have to have these two pieces in order for that to happen. Just give me that. Yes, what is it? 10. So 10 is equal to, let's see, the radius is 6 times theta. That means that theta is equal to what? 5/3, because you get 10 over 6. This 5/3. 5/3 what? Meters? Yes? Radians. Theta. If it's an angle measure, it ain't, okay? Or meters or whatever. This is in radians. Should there be a pi on there then? Should it be 5/3? Where does that come from? You don't get to just put it. It doesn't work that way. No, there isn't one there, right? And it's okay. Like when we're calculating them or converting from degrees, whatever, put a pi in there, but the radians measure can be a decimal. It can be a fraction that doesn't have a pi in it. Like there's still a value of pi in there somewhere. And I would have to, we'll figure that out when we get to degrees, but that's my radians. There's no pi. We don't just stick it in there for the sake of sticking it in there because most of the radians have pi's on them. That is my answer. But because most of the time when you have the radians, we've had pi's in there, and we don't, most of the time we don't even put units. We're going to put units on here so we don't get confused because these are radians. 5/3 radians. You don't just throw a pi in there because you feel like it has to have a pi. And take these radians and convert them to degrees. So when I take a radian measure and I convert it to degrees, what do I multiply by? 180 over pi. If you're converting to degrees, the degrees go on top. So then when I'm here, I can reduce by, right? So 3 goes into 3 once, goes into 180 60 times. So 5 times 60 is 300. So I get 300 over pi. I can't reduce that anymore. This is the theta in degrees. And it has a pi in the denominator because that didn't really have one that would just cancel out. The value's in there, but to leave it exact, it's going to look like this. Okay? Everybody okay so far? We're all good? Awesome. All right. So it says a merry-go-round rotates 2,808 degrees per ride. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? All right, so do you know the reference angle for 2,808 degrees? No, I wouldn't expect you to know that, all right? I wouldn't expect you to know what that is in radians. So sometimes on these things we have to just straight up convert, which is what we're going to do. So I have 2,808 degrees, and I want to convert it to radians. I multiply by what? Pi over 180. So maybe I can reduce, maybe I can't. I would not, if I were you, and if I'm doing this too, I would not spend any time trying to find the biggest number. I would just start reducing it a little bit at a time. So I can reduce these both for sure by what? 2, because they're both even. So 20. Then they're still both even. So I think I'd probably divide both by 2 again. So now I have 45 in the denominator. What's 4 divided by 2? 702. So I longer I put 49 instead of 45. Goodness, I don't know where that's coming from. Hang on, back up just a second. Okay, 45 makes way more sense. Now I cannot no longer divide them both by 2, and I can't divide them both by 5. Can I divide 3? All right, so 3 divides into 702. Let's see, 3 goes into 7 twice with 1 left over. 3 goes into 10 3 times with 1 left over. And then 3 goes into 12 4 times. And this will be over 15. Can I reduce any more? Is 234 divisible by 3? Yes, because that adds up. So I can do it again. So 3 goes into 23 times 7 with left over. 3 goes into 24 8 times. And then I can't reduce anymore. So instead of worrying about the big numbers, do it a little bit at a time until you get to something maybe more recognizable, or until you're done and you never really recognize anything. That's okay. If at this point you recognize that you could divide them both by 9 and you jumped right to here, that's fine too. If you can just look at it and you actually can jump to here, that's great. Don't tell anybody because we won't be really happy with you. But we're proud of you, but yeah, most of us, our brains don't work that way. So this is my theta for number 10. So now I go up here, I'm looking for S equals R theta. S equals, the radius is 8 times theta, which is 78 pi over 5. Can I reduce before I multiply? No. So I can reduce the 8 and the 5, and 5 and 78 don't reduce anymore. So I have to multiply 8 times 78. I can multiply 8 times 80 and then subtract what? 16. What's 8 times 80? 640. And then I would have to divide, I would have to subtract 16, right? And so you may or may not need to actually jot that down. But I jot that down, and that means in the numerator then I get 624 pi over 5 feet. Okay, everybody okay with that? Any questions at all? Okay, good deal. All right, Cincinnati, Ohio is directly north of Atlanta, Georgia. Cincinnati has a latitude of 39.1 degrees north. Atlanta has a latitude of 33.7 degrees north. If the Earth has a radius of 3,960 miles, how far are these cities? All right, so it's 39.1 and 33.7. Most of the time when we are dealing with these angles, they're in standard positions. So if I give you an angle measure, that angle measure starts here and ends here, right? What's happening with this is that they're saying, like, here is where Atlanta is, and here is where Cincinnati is. I'm not saying that those are even remotely close to the right angle measures, but then we're using this angle here. Okay, so it's basically give me those two, and I want to know, I need the angle in between them to figure out how far apart they are. How am I going to figure out what this angle is? Subtract. I take 39.1 and subtract 33.7. That. And you subtract. Okay, look. What's 39 minus 33? 6. So if I just do the 39 minus the 33, that leaves me with 6. That's 6.1 minus 0.7, right? So let's just do the 0.1. And that would give me 6.0 minus 0.6. What's $6 minus 60 cents? $5.40. That's where your 5.4 comes in. Even this, if you kind of do it in stages, I don't mean necessarily write that down. It's more like thoughts are happening. Maybe you need to jot some stuff down. But when you subtract, or you can vary, but clearly that wasn't working for the rest of you. So 5.4 degrees. Now I need that in radians. So I want to change that to in proper fractions. So 5.4 is 5 4/10. That becomes 2/5, right? So 5 2/5 is what is an improper fraction? 27 over 5. So that's my degrees. I need that in radians. To convert degrees to radians, what do I multiply by? Pi over 180. Okay, can I reduce multiply? Yes, I can reduce by how much? 9. 9 goes into 27 3 times, into 180 20 times. So that means my theta in 100. Okay? That's a process to get to, right? It takes a couple of steps, and you may not need to write down how many steps as I have. I just want to make sure that I'm not losing anybody in that anyway. Okay, so now I have to go and substitute all this stuff in. I have that in theta, so I know that S is going to equal the radius, which is 3960, times theta, which is 3 pi over 100. And then I'm going to reduce a little bit. So I can knock out each one of those zeros because I'm reducing both by 10. And then the only thing that divides into here is 2 and 5. Clearly not divisible by 5, right? But is this divisible by 2? Yes. Okay, so I can divide 400 by 2 and then subtract what? There's a difference of 4 here between this and 400, right? So if I divide 400 by 2 and get 200, I have to divide that 4 by 2 and get 2. So all I have to really do is do 200 minus 2, which is what? 198. So this gives me 198 times 3 pi over 5. So then I can multiply 3 times 200 and subtract what? How many extra would I have? I'd have 6 extra because 2 times 3 is 6. So what's 600 minus 6? 594. So this is equal to 594 pi over 5. And that is miles. Okay. Questions about that? That reasoning through easy multiplication, if you need to go and write some stuff out to multiply off to the side, that's fine. But that crazy work you're going to have all over the place. That's hugely important for you to be able to simplify getting through this. The S equals R theta ain't hard here. Okay. We good so far? Okay, so let's talk a little bit about area of sectors. We're going to start this, but I'm not going to finish this. I'm not even probably going to talk to the bill, but let's talk about area. Area of a circle. What is the area formula of a circle? Pi r squared. Okay. So this also is you working in radians and not even knowing it. Because where this actually comes from is that the area of a circle is 2 pi over 2 times r squared. Where once again, that 2 pi is a full rotation around the circle, right? But 2 pi over 2 is pi. That's why we use this. It would be a little bit ridiculous to actually leave it like this. But this is where it's coming from. So you take that one full rotation in radians, divide it by 2, and multiply it by r squared. Well, this gives you the entire area of the circle. We don't necessarily want the entire area of a circle. The sector just gives you the little section, right? A piece of pizza. So instead of the 2 pi, this theta is this right here. 2 pi would be all the way around. We need this part in the numerator to change when we're only looking for a sector. So the area of a sector formula is actually just whatever the theta is you're using over 2 r squared. So to make it into the actual formula, that becomes 1/2 theta r squared. And that's straight from the pi squared formula. We're just changing the full rotation to whatever theta happens to be. Okay? That's your area of a sector formula where theta is measured in radians. Very important there. All right, so let's look at number 12. It says find the area of each sector. So I have this in degrees. What do I need this to be in? Radians. Okay, so if I take 74 degrees, what do I have to multiply it by to change it to radians? 5 over 180. Can I reduce these? Yes. Okay, so 74 divided by 2 is 37. 180 divided by 2 is 90. Can I reduce that anymore? No, 37 is a prime number, so my angle measure is 37 pi over 90. So I substitute that in. S equals 1/2 theta, which is 37 pi over 90, times r squared, which is 4, so it's 4 squared. Everybody understand where all that comes from? Yes, sir. Oh, it's A, thank you. It's not S, thank you. It is the area for the area. But that first step is 0 work. I computed it all in. If I skip steps now, whatever. It's 4 squared. 16. What's half of 16? 8. So this can become 8 times 37 pi over 90. Can I reduce that? Yes. I can reduce these both by 2. So this becomes 4. This becomes 45. Can I reduce it anymore? No. And if it's reduced all the way, once I multiply it together, I can't reduce anymore. So 4 times 37, I can multiply by 2 and multiply by 2 again. What's 2 times 37? You really shouldn't have to think too hard on that. 74. Came from? Okay, so 2 times 37 is 74. What's 74 times 2? 148. So 148 pi over 45. That is the area. What do the units look like on this? Centimeters squared, because it is area. All right, on number 13, we're going to make a couple of adjustments. We're going to change that 205 to 210, and we're going to change the 11.2 to 12. All right, so 210 degrees, I need radians. What is the reference angle there for 210? 30 degrees. 30 degrees is your reference angle. What quadrant is 210 in? The third quadrant. So your 30 degree angle, reference angle there in the third quadrant, what would the actual angle be? What's 30 in radians? Pi over 6. So to get to 6 pi over 6 is what? 7 pi over 6. So when I go to substitute that in, A equals 1/2. My theta is 7 pi over 6 times r squared. That's 12 squared. What is 12 squared? 144. Half of 144 is 72 over 6. Can I reduce that? Yes. How many times does 6 go into 72? 12 times. So I cancel those back. I won't have a fraction at the end. I just have 12 times 7. What's that? 84. So this is 84 pi feet squared. And if you don't know your multiplication facts, that doesn't go quite as quickly. You need to know those. So just like I changed some numbers on number 13, I'm changing a lot of numbers on the area of the sector problem. I'm going to give you the assignment today. I don't want you to touch the area of the sector. If you go through and do the whole thing, you're going to do them all with wrong numbers and make your life way harder, because I changed them to simplify them since I want you to keep them exact. I don't want the numbers to be insane. So I fixed it where they're a little bit easier to work with so you don't end up with ginormous numbers that you're squaring. So don't even touch them yet, because we're going to finish this. I want to talk about a couple of more things tomorrow. Then I'll give you the changes tomorrow so that you can go finish it. But you can go ahead and get the front done. Okay?